So in this video, we're going to kind of take a detour from the methodologies we've been using so far to talk about how we deal with radicals of radicals. Okay, so in this case, we're looking to simplify the third root of the square root of 27. Okay, so when we're dealing with this, we're going to want to convert to an exponent here so we can simplify as much as possible. Or alternatively, you can use a rule that says I can swap the radicals at liberty. Okay, so how does this work out? We have, well, this is equal to, well, let's change this all to an exponent. So we have square root of 27 inside a 1/3 power. That's what these radicals mean. So if you have a cube root, that's equal to a 1/3 power. Similarly, square root is equal to a 1/2 power. So continuing with this, this gives me 27 to the 1/2 power, all to the 1/3 power. So this is going to be a exponent review of sorts to figure out how we can work with this most effectively. So when you have two exponents, you have an exponent of an exponent, you multiply the exponents. You multiply straight across as you would normal fractions. So what does this give us? This gives us 27 to the 1/2 times 1/3 power, and that is equal to 27 to the 1/6. Okay, so at this point you could plug this into a calculator and figure out the number, but this is kind of hard to work with at this point. You can say that this is simplified, and you wouldn't be terribly wrong, but I think we could do a little bit better. Let's take a look back at this again. We know that when we multiply two numbers together, it doesn't matter which order we multiply it in. So here we're saying 1/2 times a third. This is the same thing as a third times a half. So if I were to rewrite this, this is going to be 27 to the 1/3 power times 1/2 here, all up in the exponent. Okay? So basically undoing all of this unradicalizing that we're doing here, we have 27 to the 1/3 power, which is the same thing as the cube root of 27. Okay, and that's to the 1/2 power. Undoing that, we have the square root of the cube root of 27 here. So all we did was switch the order. You would literally, if you understand this entire train of thought here, you can literally jump from here to here. There's absolutely nothing wrong with that, and no one's going to fault you on that if that was what you turned in for your work. So now what's the cube root of 27? Maybe I can break this down using a factor tree. So I use 27. That breaks down into 3 times 9, and 9 breaks down into 3 times 3. So this is convenient because now I have a cluster of 3 3s, or 3 to the third. So what this buys me is that I have now a square root of a cube root of 3 to the third. And the cube root, since by order of operations we're working on the inside of this big radical first, I have cube root of 3 cubed. That cancels. So this leaves me with just the square root part with just this 3. Okay? So at this point we have the square root of 3. And that is the final answer in this case. So all I did is I went basically from here to here. I swapped the radicals because of how powers work. Okay? And then because of that, I was able to use a factor tree and break it down into just the square root of 3. So at this point, we are done with this example, and I will do another similar example in the next video.